So the slant height is right here. Okay? So you can kind of think about it as like the altitude of this triangle face, right? Okay? So the altitude of that triangle face. All right, something that the slant height cannot be is an edge right here. Okay, so the slant height cannot be on an edge. It has to be on the face of the shape. Okay, that's super important. Cannot be on the edge, can only be on the face. And it does form a 90-degree angle as shown. Okay. All right, so area of the base is still the same. That's just the entire area of whatever is on the bottom. Okay, something that is a little more confusing. I brought spaghetti from, our building activity to show you this. All right, so if the height is kind of what would be like inserted into the triangle and like pushed out the top. Okay, so like that is the height. So it's like the whole thing from the bottom of here to the top of here. Obviously it doesn't stick out like that. But do you see the difference between height and then slant height? Okay, so this one is through the whole shape. This one is just on its face. Okay, so that's super important that you know which one to pick. Alrighty. Alright, so if you want to label somehow your height through the shape, you can do that. Your base on the bottom. Whatever you need to do to remember all of those variables. Alright, so let's talk about what the actual formula is for the volume of a pyramid. Alright, so volume of a pyramid. Volume equals 1/3 area of the base times height. Okay, so that shouldn't surprise you too much, just because most of our volumes have been the area of the base times the height. Now we're just adding 1/3 because it is, it's not really like a full shape. It comes to a point at the top, right? So that's kind of where that 1/3 comes from. It has something to do with that ratio there. All right, so H in this case is the actual height, not slant height. So you might want to make yourself a note that it is not the slant height, it is the height. Okay. So 1/3 area of the base times height. All right. So surface area then, just a little bit different. So surface area is kind of wanky, so we got this. All right, so it's B. Oops. I'm going to go through each letter. I'm just going to write it out for you, and then we'll talk about what each one means. So B plus 1/2 PS. B, big B, plus 1/2 PS. Okay, so remember when I write a big B like that, that means I'm doing a calculation, right? So that big B is the what? Good, area of the base. I keep hitting that button. Area of base, good. What is that P? Does anybody have any guesses? Perimeter of, good, I like perimeter. Perimeter of the base, yep, perimeter of the base. So that P is just the perimeter of base. Okay, perimeter of base. All right, what do you think S is? Slant height, okay? Good. All right, so those are our two formulas that we are going to be working with today. Does anybody remember, do you see that kind of funky looking pyramid that is like on its side but at a right angle? Does anybody remember what that's called? It starts with an O. Think about your muscle right here. Remember when you're like leaning over? Oblique. Good. It's your oblique. So that would be an oblique pyramid. All right, cool. Just fun fact. All right, so does anybody have any questions on just those formulas? Okay. All right, so let's do an example. Let's look at number 1 here. All right, so I'm going to warn you, number 1 has a lot of steps. So I'm going to have to kind of like erase and rewrite and, fun stuff. All right, so number 1. So for volume, let's just start with volume. So what's formula for volume of a pyramid? 1/3. Good, 1/3. Big B for area of the base times height, right? Okay. All right, so plugging in what we have, 1/3. We don't really have the area of the base yet, so we'll work on that later. But we know that our height is what? 3, good. So it's not 3.2. That would be our slant height. It is that 3, the one that goes from all the way to the base to the very, very point. Okay? All right, let's think about how we can solve for B. What shape is that base? Good, so it's a 6-sided. Good, hexagon. Okay, so it's a hexagon. All right, so remember the very, very, very first section that we learned was how to find the area of any regular polygon, yes? Okay, so does anybody remember the formula for that? It had to do with that weird apotheme word. Weird apotheme word. Nobody remembers?
1/2 times the apotheme times the perimeter.
Good. So remember, it's 1/2 times the apotheme times the perimeter. Okay, 1/2 times the apotheme times the perimeter is your area of any regular polygon. Okay. All right. So if we think about this polygon, so we have a hexagon. Okay. So there's our hexagon. Okay, so we need to think about breaking up that hexagon because the only piece that we know is that its side length right there is 2. Okay, so we need to kind of come up with a way to find the apotheme. Okay, we're good to find the perimeter, but we can't find the apotheme. So remember, the apotheme is the center dropped down, so it's the altitude that's formed by the center being dropped down. Okay. All right, so I drew this triangle. I'm going to redraw this triangle. Okay, so I have 2. I have my right angle coming down with my apotheme. Okay, does anybody remember how we can use that triangle right there to find the apotheme? It's kind of tricky. What do I do? Yeah, so I'm going to use trig, right? So I'm going to break that triangle up right now and break it even smaller so that I have just one right triangle. So basically all I did was take this one side, bring it down. Okay? All right, so there is my one little triangle. All right, so because I split it, what do I need to do to my base? Good, so it gets divided by 2, so now my base is just 1. All right, so good. I got a good start. I have a right angle with a base of 1. Okay, but I need more, right? I can't really solve the apotheme without more information. Okay, what is something that I can try and do? I'll give you a hint. It has to do with the angles. What can I do to find an angle? All right, I'll give you another hint. I can find this angle right here. How?
Like divide something.
Yeah, I'm going to divide something. You're right. You're right. I'm going to divide something. Yep. Kaylee? Yeah, nice. Nice. All right, so 360 divided by 6, remember, will give you the central angle. Okay, but remember the central angle is this angle right here. Does everybody see where I'm drawing? Okay, so the central angle is that triangle, the big one. Okay, so I need to take whatever number I get for my central angle and divide it by 2 again, right, because I divided by 2. Okay, so what did you get for the central angle? 360 divided by 6. Good, 60. So divided by 2 would just be 30 right here. Okay, so if I have 30 degrees and 90 degrees, what is automatically my last angle? 60. So I have a 30, 60, 90 triangle. Okay? All right, so now that I know that I have a 30, 60, 90 triangle and I know some angle measures, I can use trig. So if you want to use sine, cosine, or tangent, you can use that. I think it's honestly easier just to use trig ratios, the 30, 60, 90 special right triangles. So does anybody remember what the long side is in comparison to the short side? Do what? It is? Yeah, you can use tangent for this one. If I wanted to use trig ratios, though, what would it be? What? Short side. Remember, the long side is the short side times radical 3. Good. Okay, so it would be the short side times radical 3. So it would just be 1 times radical 3. If you did sine, cosine, tangent, if you use trig ratio, you'd get the same answer. Okay, cool. All right, so now I have my apothem. So I did all of that work just to find an apothem. I know, crazy. All right, so area is going to be equal to 1/2 times my apothem of radical 3 times, now I need to find my perimeter. What would my perimeter be of my base? Good, 12. 2 times 6, right? All right, so my area is going to be then 6 radical 3. 6 radical 3. I'm going to leave it like that just because I'm about to plug it into something else. All right, so that is my area of the base, so I'm going to come down here, drop it right here. So 6 radical 3. So now I have 1/3 times 6 radical 3 times my height of 3, which gives me 6 radical 3 as my volume, because my 1/3 and my 3 cancel out. And that is going to be in inches cubed. Inches cubed. All right, does anybody have any questions on how we just found the volume of that? I know that was kind of a lot of steps. We good? All right, let's try surface area. All right, in order for me to do surface area, I'm going to have to erase all this, which is not fun, but you know. All right, who can tell me what the formula for surface area is? You guys got this. I have faith in you. You can tell me what the surface area formula is. I know each and every one of you lovely people can. What is it? I'm not going to move on until you guys tell me. We're just going to sit here and stare at each other, I guess. What is it? It's written at the top of your paper. Yep, got it.
The base.
Okay.
1/2 and then PS. So the
Okay.
perimeter of the base.
Yep. So it's the area of the base plus 1/2 the perimeter of the base times the slant height. Okay. Area of the base plus 1/2 times perimeter of the base times slant height. All right, so area of the base. Remember, we already calculated that in our last problem. It was just 6 radical 3. Okay. Plus 1/2. Perimeter of the base, we also calculated in our last problem, which was just 12. All right, and the slant height is easy because it gives it to us, yes. And that is just 3.2. So everybody see where I pulled all those numbers from? Okay. All right, so when you plug and chug that into your calculator, what do you get? Surface area is Somebody get the answer? Did anybody get it? 6 radical 3 plus, yep. What'd you get, Joe?
25.2 radical 3.
20, what'd you say?
25.2 radical 3.
I got something different.
29.
That's what I got, 29.6. Did anybody else get that? 29.6? No? Okay, so type in 6 times radical 3 in your calculator. And then you'll get that answer. And then I would do the other side separately and then add them together.
How do you find slant again?
Do what?
You find the slant again.
The slant? So it already gave it to you. It's that one that's right up and down. Do what now?
Is there a formula for the slant?
There is not a formula for the slant, but we're about to do an example where we're not given the slant, and I'll teach you how to find it. It's really easy, though. Okay? Good question. All right, were you guys more successful at plugging that in your calculator? Did you get 29.6? Okay. Alrighty. Any questions on number 1? All right, we are not going to do the entirety of number 2, but I do want to talk about some things about it because there are some things that are really, really different in number 2. Okay, the first one being, what do you notice about its base?
It's a square.
Ooh, it's a rectangle, right? So they're actually not equal, right? 11 and 7 are not equal to each other. So what makes this different is you're actually not able to use the formula on that because here's why. Notice there's an X for the slant height and the Y for the slant height. Those slant heights are going to be different because if you think about your pyramid here, if one side of my pyramid was longer than the other, so like let's say this one was longer, the time it's going to take me to get all the way to the top on this one is going to be much bigger than the one it's going to be on this one, right? So you got to think about, okay, one's going to be bigger than the other, therefore I can't use just one of the slant heights. Okay, so that's not going to work. So what you can think about doing, which is one of the big reasons that I had you create your little diagram, is you can kind of think about this as a net. So that basically just means where everything is kind of drawn out, okay? So it's kind of unfolded. All right, it's unfolded. Okay? So when you go to find the surface area, you are going to do the area of these two, right? Because those two are going to be the same. These two right here are going to be the same. And then you can just have your base. Okay, does everybody understand why the formula won't work there? Because you have two different slant heights. Okay, so like I said, we're not going to go through this whole problem, but I do want you to figure out how to calculate a slant height because notice we do not have one, right? So does anybody have any ideas? Anybody see anything clever on how to find the slant height? Yep.
I think you could like split one of the lengths of the base in half and then use that in the height and then just do Pythagorean theorem.
Real smart, okay? So, notice, for those of you who can't see that, I could not, okay? Took me a while to figure this out. All right, so 7, notice 7 is right here. If I take 7 divided by 2, that's going to be this length right here. Okay, does everybody see this? Look at this triangle that is forming. Does everybody see that triangle? Okay, so if I were to draw it this way, it would look something like this on the flat plane. Okay, so 15 would be my height. 7 divided by 2, or 3.5, would be my base. And then I would use Pythagorean theorem to find my slant height of x. Okay, so if you work all of that out, x is equal to 15.4 meters. Okay, we're using lots of skills today. All right, where are we feeling at comfortability level on finding surface area and volume of pyramid? 3, 2, 1. Okay. All right, so most of you are about a 2, which is perfectly dandy because we literally just started. And these are going to require a lot of practice, okay? Unfortunately, you got to just, this section, like this whole chapter, I'm sorry, but it's literally just memorizing the formula and applying it, which kind of stinks, I know. It's like a lot to remember, but it'll be all okay, I promise. Okay? All right, so we are going to skip number 4 and move on to a different shape. That was interesting. Okay, so if you go to page 2, now we have cones, okay? So here's our cone. All right, so for the sake of time, I'm not going to have you guys make cones because I really struggled to make this cone. Don't look at the bottom. Okay, So here's our cone. All right, so notice it still has an S on it. So cones have slant heights and pyramids both have slant heights. Okay, and a lot of the things are the same. So the area of the base is still the same. The height is still the same. It's the very point to the very base. Okay, so a lot of things are similar with cones and with pyramids. All right, so volume of a cone. This is something that it has in common too. It has a 1/3. So 1/3 pi r squared h. So notice it is the same exact formula. It's just the area of the base of the cone is a circle, so that's where we get that pi r squared from. Okay. All right. And that leaves surface area. The surface area of our cone is going to be pi r squared plus pi rs. Pi r squared plus pi rs. Okay, and that s is still going to be our slant height. Still going to be our slant height. Okay. All right, let's go ahead and work on number 1. Okay, so let's do volume first. So remember 1/3 pi r squared h. Okay, what was our radius squared here?
3.
Good, so 3 is our radius. Our height would be 5. All right, so somebody plug and chug that into your calculator. What'd you get? What'd you get? What'd you get? 47.1. Okay, what'd you get?
37.
Okay. Did everybody else get 37.7? 47.1. Okay, cool. All right, so I think that we need to practice plugging into our calculators. Would that be helpful? All right. So if I were you, how many of you use like a calculator, not the iPad? Is that the majority of you? Okay. All right, so when you do 1/3, if I were you, I'd put it in parentheses, 1 divided by 3, because you're smarter than your calculator and you know that it's, 1 divided by 3, but it doesn't know that. Okay, and then times pi, and then times 9 times 5. You should get 37.7. Are you guys able to get 37.7?
47.1.
Third times. Did I do this wrong?
Do the height.
Oh my gosh, did I use 5?
I use 5.
Oh, I put 5. Sorry, guys. Good job. You did. Good call. All right, so see, I do that a lot. I accidentally use the slant height. So that, you're right, that's 4. Okay, cool. Now what'd you get if you used 4?
37 points.
Now you all got 37.7? Okay. All right, so it wasn't a calculator issue. It was a, Miss Kidman did not write that down right issue. All right, cool. All right, so surface area, really fast then, would be, okay, pi r squared plus pi rs, yes? Okay. So now the only difference is our slant height is used at the end this time. So that S should be a 5. Okay, what'd you guys get when you did that one? What'd you get? I hear you whispering it. Say it louder. The answer.
I I got 75. What?
Thank you, John. All right, 75.5 centimeters squared. All right. So go ahead and work in your groups on number. You guys can skip number 2. It's actually no wait. I want you to do number 2. You can skip number. Which number? You can skip number 4. Don't do number 4. So do 2, 3, and 5, and I'll be walking around if you have questions.